Everyone, welcome to Inspire EDUCARE. I am Ruchi and today we will solve question number 104 of Leetcode, that is maximum depth of binary tree. So in this question we are given the root of a binary tree and we have to return its maximum depth. So what is the maximum depth of a binary tree? So maximum depth is the number of nodes along the longest path from root node down to the farthest leaf node. So let's say, for example, we are given this tree, right? And this is our root node 3, right? So what we'll do is we'll find out the length of the path to all the leaf node from the root node. So like we have 3 leaf nodes, right? 3, 15 and 7. So I'll find out the length to those nodes. So we have like from 3 to 9, the length is 1, 2, that is 2. From 3 to 15, we have this path, right? 3, 20 and 15, that is 3 nodes. So the depth is 3. And from 3 to 7, it will be from 3 to 20 to 7, that is again 3 nodes. So the length of the path is 3. So we have this 3 lengths, right? 2, 3 and 3. So what will be the maximum depth? The maximum of these 3 lengths. So what is it? 3. So our answer will be 3, right? So it is nothing but the longest path from the root node to the farthest leaf node. So in this case it is 3. So let's talk about the logic behind the question, right? So like most of the questions related to binary tree or tree questions, this question also have a recursive approach to it, right? So let's look at it. Like in the question it's given that we are given a root of a binary tree, right? So this, let's say this is a root, right? This node is a root. I'm not writing any value in it. So can I say if this root is null, right? If there is nothing there, if there is no root, right? If we are given a null as a root, can I say that the maximum depth will be 0, right? Because there is no node in a tree. If there is no node, that means it will be 0, right? So this will be our base case. If root is equal to null, that means return 0, right? Because there are no nodes in the tree, that means there will be 0 depth, right? Even if we had like one node, let's say this was a root, we could have said that, we can say that the maximum depth is 1, right? But because there are no nodes in this case, we can say that the maximum depth is 0, right? So this will be our base case for our recursive solution, right? Now let's look at a bit more complex tree. Let's take this as example. This is our root node and this is a tree and we have to find the maximum depth. So before like going into the logic, let's find out what's the maximum depth is. Can I say that this is the longest path, right? This from 1 to 5 and 6, 1, 2, 5 and 6. If we just look at the tree, can I say that this is the longest part, that is 4? So if I put this tree into the function, it should return 4, right? So how it will return 4? Let's see that. Okay, let's visualize this tree, right? Let's say I'm on the root, right? I'll be given the root and this is my left tree, right? This is my left tree and this is my right tree, right? I have divided this tree into 2 parts. This is my left tree and this is my right tree and this is the root. So if I look at the whole tree, right, I have this root and I have like divided this tree to 2 parts, this left tree and right tree. Can I say that the maximum depth of this whole tree will be 1 plus 1 for this root, right, 1 node, maximum of left and right, like the maximum height of this tree and the maximum height of this tree, maximum height of left tree and maximum height of right tree, I'll get it. And the bigger of those, like if left is bigger than left and if the right is bigger than right, maximum of both plus 1 will be the maximum height of the whole tree, right? If we visualize it, let's say this is left tree, right? So what is the maximum height, maximum depth of this tree? I can see that it is 3, right? 2, 5 and 6, right? This will be like 3. And what is the maximum height of this tree? 3 and 3, 8, that is 2. And what is bigger of left and right? 3 is bigger, right? So can I say that 1 plus maximum of left and right is 3, that is 4 is the height of the whole tree, right? So can I write like the maximum depth will be 1 plus maximum of left maximum and right maximum, right? Can I write this? And this is after checking whether root is null or not. If root is null, it will return 0, right? But if root is not null, root is not equal to null, this is the condition for that, right? And then this will be also the same function, like it will, what will pass in our function maximum depth of left, right? Root of left. And this will be maximum depth of root of right, right? So this will return the maximum depth of the whole tree. So now let's look at the code. So we have this function, right? Max depth, and we are given the root node, right? So we talked about the base condition, right? Like if root is equals to null, we'll return 0. So it's just this, that if root is equals to null, then we'll return 0. Else, as you can see, I've written like 1 for the root node, 1 plus maximum of the maximum depth of the left tree and the maximum depth of the right tree. Max of both of these, like whichever is the bigger one. If the left depth is bigger than left, and if the right depth is bigger, then it will choose right, and we'll return that 1 plus maximum of either left or right. So let's run the code for this. As you can see, we are getting the right output, and let's submit it. And it's running, right? So this was a very easy question for the binary tree. It's just, you can see like there is just 2 line of code because the recursive solution does all the magic, right? So I hope you liked the video, and thanks for watching. Please do subscribe to Inspire Educare YouTube channel for more such content. Thank you so much.